Hi everyone, so this video is going over the second page of Midterm 2 for Chem 3A at UC Berkeley, Fall 2019, taught by MaryAnn Robak. So let's dive in. Okay, so this first question is talking about acid-base reactions of this cool little molecule here. We were studying it in the first page, the stereochemistry of it. And so it's saying that we're going to do an acid-base reaction between this reboxetine and the methane sulfonic acid. And so right away we hear sulfonic acid. So we know that that's going to be the acid in this acid base. And what will be the base in reboxetine? It's going to be this nitrogen group right here. So that's a pretty well-known base, is an amine. And so so what's going to happen when we do acid-base? Acid-base means that one molecule is donating its hydrogen to the other one. So we know that this right here, the electrons are going to go on the hydrogen, and this nitrogen here is going to take the hydrogen. Right? So let's draw what the conjugate acid and base would look like. So the conjugate acid is going to look exactly like the base except with a hydrogen, and the conjugate base is going to look exactly like this acid but with one less hydrogen. We're going to get rid of this hydrogen that's attached to the oxygen. So let's just go ahead and copy down reboxetine. And we got the conjugated pi bonds, ethoxy group. Draw another hexagon here, and conjugated pi bonds. Oh, there's an oxygen there, nitrogen, hydrogen. And now we know that this nitrogen is going to get another hydrogen, so we're going to put H2 here. Or you could draw like one H here, one H there. I'm just going to write that H2. And this nitrogen is now going to have a plus charge on it. Right? Before it had one lone pair and 3 bonds. And now it has 4 bonds. 2 hydrogens and 2 carbons, so that's going to be a plus charge. So that is the conjugate acid. Before it was a base, the reboxetine, and now it's going to be the conjugate acid because we got the hydrogen. And so the methane sulfonic acid, methanosulfonic, whatever, it's going to have one less hydrogen. The hydrogen that was attached to the oxygen is going to be donated to the reboxetine. So we're just going to copy that over here without that hydrogen attached to the oxygen. And the electrons that were in the oxygen-hydrogen bond are going to the oxygen, which means that the oxygen now has an extra lone pair, so it's going to have a negative charge. Okay, so that's going to be the conjugate base. So to figure out KEQ, KEQ equals 10 to the pKa of conjugate acid minus pKa of acid. Okay, so the conjugate acid here is this ammonium group. Even though it's not NH4, it's still considered an ammonium group because nitrogen is making a bond to a hydrogen and 3 other groups. And so that has a pKa of 10, I believe. I don't have everything memorized, so let's just double check. Yep, that's a 10. Okay. So it's going to have a pKa of 10, about 10. So then for the KEQ, they gave us the pKa of the acid over here. We know the pKa of the conjugate acid. So the KEQ is going to be 10 to the power of pKa of conjugate acid is 10 minus pKa of acid. It's going to be negative 2, which equals 10 to the 12th. That's going to be the KEQ here. 10 to the 12th. That's kind of ugly looking. We're going to fix that. Okay. So that's the first part. Second part is very similar to the first one. Same directions. We're just drawing the acid base between reboxetine and succinic acid. As you can see, succinic acid is I can't think of the word. Basically, there's a mirror plane here. And so either of these hydrogens are equally likely to be acidic. We could deprotonate either of them. It would lead to the same compound. So this nitrogen, again, is going to be the basic site. And this is succinic acid. That's the key word there. So letting you know that this is going to be the one that donates the proton. And the nitrogen is going to be what takes the proton. And so let's just copy down reboxetine again. We're going to give it an extra hydrogen at that nitrogen site. We've got the benzene here. Got the OET. Oxygen. Nitrogen. H2 instead of H. And then we've got the benzene over here. Ooh, that's kind of wiggly. This is not pretty. And they drew the lines like this. Okay, I think that's everything. Yep, so now this nitrogen is going to have a plus charge because it made one of its lone pairs into a bond to hydrogen. And then we're going to copy down succinic acid. One of those hydrogens that are connected to the oxygen are going to be gone, so let's just take away the top one. And when we took away the hydrogen from here, from this oxygen right here, the lone pair went onto the oxygen, so now it has 3 lone pairs and 1 bond, so that's going to be a negative charge. Okay, so again, this is going to be the conjugate acid. This is the conjugate base. So to figure out the KEQ, we need to know the pKa of the conjugate acid, and that's going to be about 10 again. It's another ammonium ion right there. So that's going to be 10 to the, and succinic acid, that's one that we should have memorized. Oops, okay. Succinic acid, I think that is, don't even remember. Okay. Oh, that's a 5. Okay, that's my bad. I wrote those all on my cheat sheet for the final. So, I don't have that memorized off the top of my head. But, so yeah, let's write that down. pKa is about 5, or it is 5, and its conjugate acid is 10. So again, we're going to do 10 to the 10 minus 5. So that's going to be KEQ equals 10 to the 5th. If you haven't already done your cheat sheet and you're in the class right now, that's something I recommend putting on your cheat sheet, is the pKa's of all those things we're supposed to have memorized. Because I know I forgot them. Anyways, so the third question on this page is 3A. And it says classify the roles of the reactants based on the balanced equation for reaction A. So we have to look at the reactants and the products in this case to determine what each of these things are. So let's look at this amine. It becomes an ammonium. So it goes from 3 ethyl groups on a nitrogen to 3 ethyl groups on the same nitrogen and a hydrogen. So what is something that takes a hydrogen from something else? That's a base, right? And so you might be tempted to be like, oh, this is obviously a base, so the other thing is going to be an acid, but that's not the case because this isn't just one step, it's a multiple mechanism step reaction that we're looking at here. So we actually have to look at everything that's happening. We have to kind of figure it out in our head, not necessarily the right order yet, but we need to think about like everything that's happening here. So we need to figure out where the hydrogen is coming from that goes onto this nitrogen. So there's a hydrogen that comes here. Where is it coming from? So if we look at this site here, the OH there versus this, we see that this group right here is basically getting added on to this oxygen, right? We're getting rid of this chlorine that ends up here at the end. And then this sulfur attaches to the oxygen and the hydrogen goes away. So that's the hydrogen that's going to go on this group. Sorry, that might be confusing. I'm not really explaining like what order it's going to happen in because that's not really something that I would have been thinking about during the test at this point. Just kind of trying to determine like how everything is being moved around, you know? So this chlorine, we can see that that's leaving because at the end it ends up by itself. We see that the sulfur is connected to, it's double bonded to 2 oxygens and it's connected to a methyl group, and that stays the same here. Let's highlight that in a different color. Just go a little bit darker. So over here, this part all stays the same. This part stays the same. We know that this chlorine is leaving with its electrons, so the sulfur is going to kind of intermediately have a plus charge on it, or it's going to be making one less bond. Electrons are being taken from it. We know that when the amine takes the hydrogen, it's not taking the electrons. The electrons are going to be left on this oxygen. And so when we're trying to determine what the role is of this molecule, we see that it doesn't have a lone pair. This oxygen has a lone pair, so that's what's going to be attacking the sulfur, right? You can kind of see that that's what's going to end up happening because the chlorine took its lone pair, and so it's the lone pair on the oxygen that's left after the hydrogen leaves that will be attacking the sulfur. And so the oxygen here, this is going to be the nucleophile. It's also the acid because it's donating a hydrogen, but at this part it's going to be the nucleophile, and the sulfur is going to be the electrophile because it's taking electrons into a bond that it didn't have before. And the oxygen is donating electrons to make a bond, which makes it the nucleophile. Okay, so that is the second page of midterm 2 for Chem 3A.